we are required to find the radius of this small circle. So as you can see, we have this small circle and this big circle. The big circle is tangent to this line at this point and at this point. Also, the small circle is tangent to the same line at this point and at this point, and also tangent to the big circle. And the radius of the big circle is 1. So let's find the radius of the small circle. First, let the center of the small circle be O. Okay, and let that of the big circle be C. Now let this be A, this point of tangency, let it be B, and let this point of tangency be D. And let this one here be E. Okay. Next, let us connect center C to point A. So I'll just connect C to A, just like that. As you can see, this line passes through this point of tangency E, and it also passes through the center of the small circle O. Next, let us connect center C to point of tangency B and point of tangency D. And also connect to D, just like that. As you can see, BC and DC are radii of the big circle. And you know that radius of the big circle is 1. So this is 1, this is 1. Now we know that from tangent to a circle theorem, the angle formed when the radius and the angle formed by the radius and the tangent to a circle is 90 degrees. So this is 90 degrees. This is also 90 degrees. Now we can see that ABCD is a square. So side AB is equal to AD, which is equal to DC, which is equal to BC. And we know that this is 1. So also this side AB is 1, and also AD is 1. Now focusing on triangle ADC, we can see that it's a right triangle. AD is 1, DC is 1, this is 90 degrees. So we want to find the value of AC. Since it's a right triangle, we are going to use the Pythagoras theorem to solve, which is A squared plus B squared is equal to C squared. Okay, so our value of A is AD, which is 1. So 1 squared. Our value of B is DC, which is also 1. And our value of C is AC. So AC squared. So AC squared will be equal to 1 squared is 1 plus 1 squared is also 1. So AC squared is equal to 2. Find AC, we have to find the square root on both sides. And so AC is root 2. So our value of AC is root 2. Now focusing on our small circle, let this point of tangency be F and this G. Okay. Next, let us connect center O to point F. Connect O to F and O to G. Okay. As you can see, FO and GO are radius or radii of the small circle. Now let the radius of the small circle be R, small r. So this will be R, this will also be R. But since we know that from tangent to a circle theorem, the angle formed by the tangent and radius is 90, so this is 90, this is 90, implying that AGOF is a square. So if it's a square, all the sides are equal. So all the other sides are R. Also this side is R, this side is R. So now focusing on triangle AGO, this small triangle here. It's a right triangle, so we're also going to solve it using Pythagoras theorem. So a squared plus b squared is equal to c squared. Our a is r, so r squared plus our b is also r is equal to our c is AO squared. Okay, so r squared plus r squared gives us 2r squared. This is equal to AO squared. So to find AO, we shall have to find the square root on both sides. So AO will be equal to, this is the same as root 2 times root of r squared, which gives us root 2r. R squared, this cancels with the square root, so we have root 2r, which is the same as r root 2. So AO is r root 2. But remember, AC, the whole line AC is equal to AO plus OE plus EC. Okay? Plus EC. But remember, we got our AC, the whole of AC as root 2. So root 2 is equal to our AO, we have got it as r root 2. Our OE is the radius of the small circle, which is r. And our EC is the radius of the big circle, which is 1. Okay, so let us take root 2 on the other side and bring the values with r on this side. So we shall have r root 2 plus r is equal to root 2 minus 1. Okay, so here r is common, we factor it out, we shall have r into root 2 plus 1 being equal to root 2 minus 1. So let us divide by root 2 plus 1 on both sides. Root 2 plus 1, this cancels. And so r is equal to root 2 minus 1 over root 2 plus 1. Now let us rationalize the denominator. We are going to multiply this by the conjugate of the denominator, which is root 2 minus 1, both numerator and denominator. Okay, so now r will be equal to, we multiply this times this, it will give us 2 minus root 2 minus root 2 plus 1 over, remember root 2 times root 2 is 2, root 2 times negative 1 is minus root 2, minus 1 times root 2 is minus root 2, minus 1 times minus 1 is positive 1. So root 2 times root 2 is 2, then root 2 minus times negative 1 is negative root 2, then 1 times root 2 is positive root 2, then 1 times negative 1 is negative 1. And therefore r is equal to 2 plus 1, which is 3, minus root 2 gives us minus 2 root 2 over 2 minus 1 is 1. Then minus this cancels with this. So 2 minus 1, we are left with just 1. Therefore, the radius is 3 minus 2 root 2. And that's our answer for the radius of the small circle. Thank you so much for watching. Kindly subscribe to this channel for more amazing videos. If you've enjoyed the video, kindly give it a thumbs up and also share the video with your friends and family for an enlightening experience. Those who haven't subscribed yet, please do so. It's completely free of charge. It helps push the videos to more people. Thank you so much. Let's meet in the next video.